Okay. So in math, go up. Summation notation, 0. 0. So the sum. Calculator doesn't have I have to use x. 1 till 5 from I squared. I don't have I have x. When I press enter, I have to get 55. If I don't get 55, I have to go back to the drawing board and see what happens.
You click X instead of 5 there.
Oh, I put X. Sorry.
So why is it equal 91?
It has no reason. It couldn't calculate more, I guess. Sorry. When I click enter, I have to get 55. If I don't get 55, I have to go back to the drawing board. So that's how we determine the sigma notation. Okay. So, of course, every time a notation is invented, it comes with properties. So the sigma notation has properties. But the properties are common sense. There is nothing unusual here. So the sum, now that I squared normally is denoted by AI, BI, something like this. So from I equals 1 through n, from AI plus BI. These are generic terms. Or minus. We've worked on with this property over and over for the derivatives and for limits. All of them have the same property. What is it? It's the sum of AI plus the sum of BI. I is the index. So from I equals 1 through n, from I equals 1 through n. If this is minus, of course this is minus. What does this mean again? The sum of two generic terms is the sum of the sum of those generic terms. The sum of the difference of two generic terms, of course, is the difference of the sum of those two. I put them together. Have we ever seen this before? Well, yes, of course. F plus G prime is F prime plus G prime. That's exactly the same. Another one, limit of F plus G as x approaches A is limit of F plus limit of G as x approaches A. It's the same property. If I have minus, of course, same thing. Same concept. Yes, it's a different idea, but it's the same concept. Meaning the derivative of the sum is the sum of derivatives. Same thing here. And of course, there is one more. The sum of a constant times AI from I equals 1 through n. We've dealt with this property before. The same thing with A times a function prime is A times F prime. The limit goes outside. What do you think will happen here? So this is a constant that does not depend on I. It can be pulled out. So see the sum of AI from I equals 1 through n. So not only that we invented this notation, and what's the use of it? Why would this be so important? Here's why. What if this is n? If this is n, where will I stop? It goes on forever till n, right? So this will be condensed, the sum from I equals 1 through n from I squared. Just one simple notation instead of listing as many terms as I can. Nobody wants to do that, but this will be very clear. So here it is. So if I have something like the sum from, let's say, 3, I cubed from I equals 1 through n, I will write it as 3, 1 cubed plus 2 cubed plus dot, 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 exactly 3 dots plus n cubed. from I equals 1. When I is 1, I have 1 cubed. When I is 2, I have 2 cubed plus dot, 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 and I have to stop at n. Nobody wants this notation. It's cumbersome, but this is very clear. But that's what it means. So we have to present it so we understand what it means. So again, the sum from 3i cubed from I equals 1 through n. 3 was a constant, a factor, so I took it out and I wrote this. Any questions? And yes, I didn't tell you what we're going to do with this. In a moment, I'll get there. What's the whole thing? What's so important about the summation notation? Okay, I just want us to work on one more. Let's say the sum from I equals 1 through 10 from 3i squared plus I. What does this mean? It means 3 times 1 plus 1, 4, plus, when I is 2, 3 times 4 is 12, 12 plus 2, 14, plus, dot, 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 I'm not going to calculate anything, so I have 300 plus 10. That's the last term. What is the answer? I don't know, I just made it up. And I hope the calculator can give us the answer. It may or may not. If the numbers are too big, it's not going to be able to. It will exceed, oh, I didn't mean that. It will exceed the capacity. We'll see. Hopefully it's not. So it's 0. So I equals 1. 1. Not 4, but 1. Okay, up to 10. And then in parentheses, we have 3 I squared and plus I. And I press enter. I have no idea what I'm going to get because I did not think in any way, shape, or form. I just wanted to give you an example. 1210. Not too bad. So again, what does this mean? When I is 1, 3 plus 1 is 4. When I is 2, 4 times 3 is 12, 12 plus 2, 14, dot, 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 and then I didn't want to calculate anymore, and I put in the last one, 3 times 100 plus 10. That's the last one with 10. Okay, so what's the use of all this? Finally, we're getting to it. So the question is, why summation notation? Why? Why do we add? Here's why. So there are 4 formulas that we can prove using mathematical induction. If you want, we can prove any of them. I have to explain to you what this procedure means and how it works, but we can prove them. So these have to be remembered. Of course, you can bring your notes in, so please remember the sum from I equals 1 through n from 1. When I is 1, 1 plus y. When I is 2, 1. When I is 3 plus 1. When I is 4 plus 1. When I is 5 plus 1. Plus 1 plus 1 is n. So if anybody asks me the sum from I equals 1 through 10 of I will say 10. Second one, the sum from I equals 1 through n from I. What is this? 1 plus 2 plus 3 plus 4 plus dot, 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 n. I'm going to write it. 1 plus 2 plus dot, dot, dot plus n. And this is a formula. n plus 1 divided by 2. How come? Yes, If you say calculate the sum from I equals 1 to 100 from I, no problem. I put 100 times 101 divided by 2. I'll simplify, and I get 5050. And you can check this with the graphing calculator. It's a piece of cake. So 0. Okay. So from I equals 1 to 100 from I. And when I click enter, I have to get 50/50. And that's it. We didn't need the calculator because we had the formula. All I had to do is just plug in n. 100 and 101 divided by 2. 2 more. Here's the next one. The sum from I squared from I equals 1 through n. What is this? 1 squared plus 2 squared plus dot, dot, dot. Exactly 3 dots plus plus. N squared. This is the most cumbersome to remember. It's n, 2n, n to n plus 1. Nope. Sorry. I need to write in the correct, it doesn't matter, but I want to write in the correct order. N plus 1 to n plus 1 divided by 6. So I said n plus 1, but I wrote directly to n plus 1. So n plus 1 to n plus 1 over 6. And the last one, number 4, I'm going to put it here because I don't have enough room, is the same with I cubed. I cubed from I equals 1 through n. Easy to remember. It's the same thing with this, but everything squared. So these are 4 formulas that we have to remember. Or have it on paper. Okay, finally, what are we doing with this? So please remember, the sum of 1 is n, the sum of I, n plus 1 over 2, n plus 1 to n plus 1 over 6. That's the most difficult to remember if you want, but these two are the same. For the I cubed, it's the same but squared. Okay.
Hold on, can you go back? Because you said it's this.
Yes, so these two are the same, but this one is squared.
Oh, up there. I thought you were pointing to the one with the denominator of 6. And
No. That's in a category by itself. So these two are the same. The one with I and the one with I cubed are the same, so to speak. But this one is not squared, but this one is squared.
Gotcha. Thank you.
Thank you. Okay. 13. Okay. Let's suppose I have a function, and this is the velocity. And I'm looking at the velocity function between t or hours x equals 1 to 7 hours. So this is in hours. And since this is velocity, this is in miles per hour. Okay. I'm looking at this area under the graph of the velocity. And you can say, you lost your mind. Who cares about this area under a velocity function? Who cares? Well, it turns out that this area is the total distance that I cover driving from 1 to 7. Covered on 1 to 7 hours. That's why this area is so important. I don't have the distance function. I am given the velocity function. If somehow I find a way of determining this area, then I automatically determine the total distance covered between 1 and 7 hours of driving. Here's another question for you. What if instead of velocity, what if f of x is the marginal cost, the c prime? What will the area represent? If this is the velocity, the area represents the total distance. If this function now is the marginal cost, in other words, what will the area represent if this function is the marginal cost?
Just cx.
Total cost.
Or yeah, total cost.
Cost for between 1 and 7 units that I manufacture, 1,000 and 7,000, 1 million and 7 million, I don't care. On 1/7, whatever the measurement unit is. What if f of x is the profit prime? What would be the area then? What will be the area if this function now is the marginal profit?
Total profit.
Exactly. So you got the idea. So this area is a big deal. Big deal. Okay. And you can say you still haven't shown us the connection between this and this. You're talking about something else now. Yes, I am. But I will connect it in a minute. So I'm going to choose a simple function. Let me stop this video.